Hello, good evening. I just realized that I forgot to like complete the assignment. I've completed the first one. I just forgot to. I just thought I forgot to record a video on the other assignment. So I will explain how we can implement stacks and queues using a linked list, and also I will go over the time complexities for the common operations. So the first part was talking about implementing a stack using a linked list. So to implement a stack, we can use a single linked list where we treat the head of the list as the top of the stack. Then we use push to push a new element. We create on a new node and then insert it at the head of the list. So this is like a constant operation. So after that, we use something called pop to pop the top element, and we remove the head node and then also update the head to the next node again. This takes a constant time. And also we also use get stop. So the get stop, what we do is that to get the top element without removing it, we just return the value at the head. This, and then it also gives us a constant time, you understand. So under the empty set, we check if the head pointer is now. You understand? We check whether the head pointer is now. The head is on pointer is now. Then we simply check the constant time. So this approach is fast, efficient, because we avoid traversing the list for any stack operations. On the second one, it talks about implementing a queue using a linked list. So to implement a queue, we both use the head and the tail pointers. And we singly link the list with both the head and the tail pointers. So there's something called enqueue. To enqueue, it means to add a new element we insert at the tail. Since we have a tail pointer, we can add a new node at the end in the constant time. And also the dequeue. So dequeue is to remove an element. We remove an element. So what we do is that we take it from the head of the list and we update the head pointer. You understand? And also under the size, we can maintain a counter that updates on every enqueue and dequeue, so that we check the size of the constant time. And then at the empty, we similarly, like it is like the first operation, we check if the head is now, then it will give us the constant time. In summary, when we are using a linked list, you have to keep track of the stack and the queue operations to make it efficient, especially when we choose the right and this one. When we choose the right end of the list for the insertion and the removal, the stack operations is overall a constant one, and it gives us a queue operation which also is a constant one if we use both the head and the tail pointers. So thanks very much, and I'm sorry for submitting this assignment not on time.